Example 7.7. For circuits used for transporting electric power, a low power factor implies large power loss in transmission. Explain. Power factor can often be improved by the case of a capacitor of appropriate capacitance in the circuit. Explain. Okay, we'll take the first part now. Power factor. What is the power average power formula? VI cos phi. Now, P by V equal to I cos phi. What is in the question? For transmitting electric power, while transmitting electric power, they will keep a fixed voltage. Anyway, power is also constant. Voltage is also constant. Voltage grid directly. For a fixed voltage only, they are transmitted. So, power as well as voltage both are constant. Now, at a given power and voltage, so it remains constant. So, P by V remains constant. I cos phi is constant. That is, as cos phi decreases, current increases. But if current increases, what happens? Loss is I square R. As current increases, loss is increases. Therefore, for a low power factor implies large power loss in transmission. We'll go for the second one now. Low power decreases, current increases, so I square R also increases. Second part of the question. Power factor can be often improved by the use of capacitor. Okay, now we'll go for power factor. Capacitor has to improve the power factor. That we have to show, right? Yes, cos phi is equal to power factor formula. If it is LCR circuit, cos phi equal to R divided by root of R square plus XL minus XC whole square. Without capacitor is not there. Then you remove this capacitor. It becomes R square plus XC square. Denominator is decreasing. XL minus XC, only XL, sorry, denominator, XL value. Denominator is increasing, so cos phi is low. When capacitor is not there, that is only LR circuit, cos phi value becomes low. I repeat, capacitor not there, this term is not there. So denominator increases, 1 by increases becomes decreases, cos phi is becoming low, cos phi is decreases. Okay, now capacitor is added to the circuit. What happens? We have to take all the terms. When capacitor is added, XL minus XC, here only XL. Now it is XL minus XC, means denominator value decreases. So 1 by decreases increases, cos phi value increases. So when capacitor is added to the circuit, cos phi value increases. If you choose XC equal to XL minus XC equal to 0, then power factor becomes maximum. So as capacitor value introduced, power factor, what happens? When you are introducing here, XL minus XC, denominator decreases, power factor increases. Power factor can often improve by using the appropriate capacitor.